Hi, hello there. Welcome back to my channel. Okay, now we already halfway through this syllabus and we are in this chapter 4 now, where we're going to discuss and focus on the workload management in the data warehouse. So previously you already learned all about processing and a part of the initial processing, we need to design the system to sustain the performance and remain scalable and remain financially viable for any enterprise. Right? To answer to this lies in understanding the workloads that happen in the system today and the future and create architecture that will meet these requirements. So that is why it is important to understand uh, everything about the workload and workload management in the data warehouse. Okay, we're going through in this chapter, we're going through the concept of the workload and how to create a solution based on the workload of processing data for each data types and its final integration into the data warehouse. Right, let's go through the content first. Okay, so there is a 5 subsection under this topic. Okay, we're going to start with understanding workloads and then query classification and then ETL and CDC workloads. What is in ETL? I already explained to you. Okay, what is ETL in previous video? Okay, you might want to check it out. But I'm going to explain later on. Okay, more details about ETL and CDC. Right, and then we're going through current system design limitation, and then lastly we're going to explain about the new workloads and big data. Right, let's start with the understanding the workload. Okay, what before we understand the workload, what does the workload mean in data warehouse? So we're going to the definition first. Okay, according to the, if you Google the workloads in there's a lot of definition, okay, but according to dictionary.com, okay, here, so it is stated that workload is defined as the amount of work that a machine produce or can produce in a specified time period. So it's like you as a student, okay, this is workload in data warehouse. We are talking about a machine, but you can read it yourself as a student. Okay, let's say you as a student, you has a registered for the first semester or this current semester, and then you have a assignment, task, quiz every week. So all that assignment, quiz, test, and every other for every courses, that is workload for you. Okay, same goes with the machine. Okay, the workload, okay, the amount of work that a machine produce. So what that produce and have to produce in specified time period. So they have to meet the time. Same like your assignment, there is a ample time that you have to submit when you have to submit the assignment. So that kind of workload with similar, but this is application to the machine. Okay, applying this definition to a data processing machine. Okay, by this definition, we apply it to this machine. Okay, the definition will slightly different. Okay, it's about the query processing of the database in terms of throughput, or how many row or seconds we have read or written, or in system terms, inserted, updated, or deleted. So this is all the system terms lah, which more specific all the definition in the data warehouse. Right, let's move on to the understanding. Sorry, before that, we need to know why we need to understand workloads better when discuss data warehousing. Okay, before we understand the workload, we need to know this why. Okay, this is question here. So the answer is because the design of the next generation data warehouses will be largely focused on building workload characterized architecture and integrating them through logical layers. Okay, so this is why we need to understand the workload lah, because we want to design the next generation, the next generation data warehouse. Okay, that will be largely focused on building workload characterized architecture. Okay, this is very important. Okay, another perspective to look regarding workload is to understand the need for static versus dynamic system. Okay, what is this static versus dynamic system? Okay, for the static, for the static, let's say a low-end digital camera. Okay, it is a static system. Okay, for dynamic, okay, let's say the camera, okay, digital camera, okay, it is designed once and must produce with the only requirement being how many pictures it can take in different settings provided as options. There is not much room to change the basic architecture of camera until you start talking about high-end devices or light field cameras, whereas a data warehouse can receive different data types and process requests from a different types of user in the same time frame or across different times in a day. So this is what talking about the dynamic. Okay, dynamic is moving something. A static system is like the camera, it is fixed. Okay, there's a low and digital camera. So that's an example for you. Okay, so let's take a look at this figure. Okay, this is a classic system architecture. Okay, these figures show the classic system architecture and the associated behaviors of each portion of the system. Okay, there is for system here. Okay, if you closely follow the trail from the end user application, okay, here, okay, to the database storage. Okay, it can be both sides actually. There are multiple steps of data movement and processing across the layers. Eventually, we also see that each layer has to wait on the subsequent layer before a final processing step can be accomplished. So we often address a symptom when a problem manifests rather than take a holistic approach from the big picture. Okay, this isolated problem addressing technique needs to change for designing and addressing scalability and performance demands for today's users. Okay, right. Additional aspect to keep in perspective is the ever-changing nature of data and associated structure. Okay, this is why we need to upgrade. Okay, we cannot use this classic system architecture anymore. Okay, the impact of data itself is one of the most ignored areas that affect workloads of the data warehouse and data marts. So there are two categories here. Okay, of data that adversely affect workloads due to their volume and special needs for the security in certain categories, which are persistent data and volatile data. So what is persistent data? Persistent data is that is needed to be maintained for compliance and regulatory reason and cannot be deleted or archived for a period of time. So it cannot deleted for a certain time. It has to be maintained. And for persistent data, the data is of a value for a shorter lifespan. But once the intelligence are drawn, the data is no longer useful to maintain. Okay, it's a very shorter lifespan only. Okay, so these are two categories of data that will affect the workloads due to their volume and special needs. Okay, okay, now we are at this part, okay, understanding workloads. Okay, in the figure previously, there is a classic system architecture. Okay, I already shown you previously in the figure. Okay, for the traditional or classic system, the workload management today is centered on the database. Okay, the primary reason for this situation is due to the fact that we can analyze. So we can analyze what happened in the database when a query is submitted. Okay, and then based on the result, okay, we interpret if there are any issues. Okay, within the outside or within the database or outside the database. Okay, as a result of this approach, okay, today we define workload from the database perspective, okay, alone, regardless what happened in the entire system. So we take a look at the standalone system, okay, not the from the point of view of the entire system. Okay, this is not good lah. Okay, usually the result that discuss for workload, okay, like speed usage, elapsed time of query, the number of SQL execution, and total users on the database. Okay, based on this, all these results, we inferred what performance impacts experienced in the current state and what can be experienced if there are spikes or increases or decreases of workloads. Okay, the resulting definition from these exercises often fail to produce the right architecture decision. So we want to avoid this. Okay, later on I will show you. Okay, the figure, okay, that shows the problems areas that manifest in the data warehouse today lah. Okay, so we can bucket this problem under each segment to understand the overall workload aspect of the system. Okay, what is the aspect of the data warehouse affected by workloads? The data warehouse inbound and data warehouse outbound. So we going to take a look on these two different aspect lah. Okay, we go. This explain on the next slide. Look at the classic data warehouse problem manifest. So this is a outbound side. Okay, and this is the inbound side. There are several recipients of data from the data warehouse, including the end user, applications, data marts, and analytical database. We going to go through one by one. Okay, for the end user application, it's include the reporting, analytics, web, and desktop application that directly interact with the data warehouse. Okay, we include this web. Okay, web application, since many reporting or analytic application can be used on a pure play web browser or mobile application. Okay, this is very important for end user. Okay, are we going to discuss this later on? Okay, data marts. Because there is rarely explanation on this data marts. Okay, this is actually a smaller version of the data warehouse which deals with a single subject. Okay, more details you can Google it or you can go to dataacademia.com. Okay, there's a lot of explanation on the data marts in the internet. Okay, and then we're going to go through analytical databases. Okay, when it can be executed within a data warehouse or outside, it's a separate infrastructure but separate we create an issue. Okay, what is an issue? We're going to take a look at this later. Okay, for the end user application, okay, for the data outbound to users, okay, in the overheads, okay, the end user application layer adds security constraint to the data based on the user who is accessing the application. So basically, the security layer is added, and then because of its dependencies, okay, the processing capabilities of the application at the end user will depend on the amount of the disk, memory, cache, and processor, okay, that is available to the application. Okay, if the data is large, so that means there has to be there has to be multiple cycles of exchange between the application server and the end user system. Okay, because of this large volumes, it will be the traffics. Okay, it will cause the traffics and waits. Okay, the loading time. Okay, so the will affect the end user because of dependencies of the processing capabilities. Okay, for the issues, there are many times due to the volume of data and the amount of elapsed times when waiting on the data. Yeah, it's related with the dependencies of that. Okay, the end users will lose a connection. Okay, due to the server timeouts. Okay, I think many of us has experienced these issues. Okay, as the end user, okay, we keep has a issue like loading. We have to wait longer time to open certain application or website. Okay, and then sometimes it's getting error 404 502. Okay, so that kind of issues that we face as an end user. Okay, and then note here, the situation is similar or even worse when you remove the application server and directly connect to a data mart or data warehouse. Okay, and then workarounds. The current workarounds is include special tables or views and or views at the database layers, semantic layer filters and data structures, adding security filters to queries, adding infrastructure to process data and move data faster, and its complexity is the data within the data warehouse is clearly articulated for usage by the enterprise. Okay, from the outbound perspective, this is the biggest area of complexity lah. There's a many processing iteration from a transformation requirement and different types of operation are worked upon to complete the query's requirement. Okay, so that's a kind of complexity. Okay, the goal is to create an effective workload strategy at this layer is to minimize the amount of work to be done by this layer and to manifest the dashboard report or metric. Okay, for the inbound to user, usually rarely the end user application rarely send data directly to the data warehouse lah. Okay, usually the inbound data come from the ETL processes. Right, let's move on to the next one. Alright, for data marts, okay, this is a much or less end user tadi just now. Okay, for the data outbound to user, so overhead SIM. Okay, is a security database on the user who is accessing the application SIM. Okay, still a SIM dependency. Okay, depends on what amount of disk, memory, everything lah. So issues also because of the many times volume of data, so we kept waiting and lost connection and okay, because of the server timeouts everything. Okay, and then the node, okay, some SIM. Okay, the session is similar or even worse when you remove the application server directly to connect to a data mart. Okay, except there is no data warehouse here. Okay, only we focus on data marts. Okay, for the workarounds, the current workaround includes special tables, still the same. Okay, the security, everything, heading infrastructure to process data and move data faster. Okay, for its complexity, okay, this is the difference between end user with data marts. Okay, the most complex operation at data mart layer are a hierarchy-based processing of data and referential integrity measurement between data structures that need to integrate data across different layers of granularity and sometimes in non-relational techniques. Okay, that's how complex the data marts. Okay, lastly, the goal. The goal for creating an effective workload strategy at this layer is to minimize the amount of work to be done at this layer. Okay, this is same with the end user. Yeah, data inbound to users also similar with the end user. Okay, end user application rarely send data directly to data marts. Okay, the inbound data come from the ETL processes. Okay, this is similar. Right, lastly, the analytical databases. Okay, that can be executed from within a data warehouse or outside as a separate infrastructure. Okay, so there is two ways. It's either you execute within a data warehouse or you outside the separate infrastructure. Okay, but there is issue if you execute it outside the or separate the infrastructure. Okay, if you use the separate infrastructure, the tendency, okay, there are extremely large data set that need to be moved between the data warehouse and the analytical database in a bidirectional manner. Okay, so there will be issue there. Okay, the tendency of large data set that need to be moved between these two things lah. Okay, so it is, I think it's easy to execute within the data warehouse. Okay, for the overheads, okay, the end user application adds minimal overhead from the analytical application. Okay, its dependency is the process capacity of the application at the end user, so this is still the same. Okay, the issues, the large volume of data, okay, still the same. Okay, look around, special aggregate structure at the data warehouse data mart, special network connection between the analytical database and data warehouse to bypass the enterprise network and avoid clogging it. Okay, adding infrastructure to process data and move data faster. So you can make it separate, but make sure you add the infrastructure to process data and move data faster. Okay, our goal is the goal for getting an effective workload strategy at this layer is to minimize the amount of work to be done by this layer. Okay, this is the same lah. So all the goal for these three are the same. So we want to create an effective workload strategy. Okay, and for this analytical database, okay, we did this. Okay, by shifting the data processing to the data warehouse or the underlying database in a shared server architecture with the data warehouse and restricting the data volume to be moved across. So we restrict this. Okay, we don't want the data volume to be moved across lah. So that all these three will improve the overall performance of the application. Okay, that is some goal. Right, as a summary, to summarize, the outbound data processing from the data warehouse generates workloads that will require processing of data several times to the same application and processing several such applications at the same period of time. So it's required several times on the same application. So our focus area for workload management that impact performance include database, storage, servers, and network. Right. For the data warehousing bounds, okay, we focus on these two. Okay, extract, transform, and load. For short is ETL application, and then change data captured. For short is CDC. So that is CDC. Okay. The next slide. Right, there are primarily four categories of workload. They are generated today. So there are four types of query classification. First is wide. Second is wide narrow. Third is narrow, and the last one is narrow wide. Okay, I'm going to look at one by one at the next slide. Right, first is wide. Okay, this is a queries from analytics for multi-dimensional analysis and can also be triggered by ad hoc uses and return long sets of columns, typically joining more than two tables in the result set. Okay, the resulting complexity from these queries are impacted by these four: length of the table, distribution of the table across the storage, data model, and data relationship. Okay, typically these queries exhibit the following traits. Okay, there are 5 traits here: long running from a perspective of time, a lot of input-output action, multiple cycles of read, heavily skewed joins, and minimal compute. Okay, next. Wide or narrow. Okay, this one queries that are generated by standard reports and dashboards and run execution on wide columns for more than two tables, returning a narrow set of columns in the result set. Okay, the complexity lies within the length of the sort table, distribution of the table across the storage, data model, data relationship, and computation. Right, typically this queries exhibit the following trait: medium cycles of execution, high memory consumption, mixed CPU utilization, and lots of computes. Right, next. Narrow or wide. Okay, this queries generated by ad hoc users or analytic users and run execution on a narrow set of columns from 2 to 4 tables, returning a wide set of columns in the result set. Okay, the resulting complexity from this query are impacted by this. Okay, length of the table, distribution of the table, data model, data relationship, dimension, and semantic layers functionality. Typically, this queries exhibit this following traits. So there are 5 traits: long-running mixed input-output, multiple circles of read, heavily skewed joins, and heavy computes. Okay, last one. Narrow or narrow. This query is generated by standard reports and run execution on a narrow set of columns, summarize table or aggregate structures, returning a narrow set of columns in the result set. So the resulting complexity from these queries are impacted by these 5: length of the table, distribution of the table across the storage, data model, time dimension, and semantic layer functionality. Okay, typically these queries exhibit the following traits: smaller input output, high CPU consumption, high memory utilization, multiple cycles of read, and heavy computes. Okay, that's the 4 query classification and all the explanation regarding the queries. Okay, another big impact on the query performance comes from the integration of data in the query from a non-RDBMS structure. Okay, for example, files like Excel, CSV, and other storage structures. Okay, the impact on the workload performance is the actual loading of data into memory from the file for each cycle of operation and managing the intermediate data sets. This query affected here are all across of the different types of classification. Okay, districts lah. Okay, structured on semi-structured data. Okay, based on district, large input output cycle, high CPU consumption, high memory utilization, heavy compute, long waits of execution, and lots of temporary storage. Okay, usually file-based data in the traditional data management platform is a threat to increasing the and skewing workload since they are managed in a serial fashion in terms of read and writes. Okay, in the traditional data integration architecture, there is no parallelism involved in file-based operation due to consistency management, which has been a big difference in the performance and negatively impacted workloads. Okay, while queries by themselves are a problem when it comes to workload management, the associated data integration challenges that are present in this layer of the architecture make it one of the most complex areas to design, maintain, and manage on an ongoing basis. Okay, the type of data. Right now, we take a look at the ETL and CDC workload, as has been mentioned before. Okay, this is a figure of ETL or CDC workload categories. Okay, for here, existing data, new data, reference data, and master data. Okay, type of workload for existing data, DML or DDL, and raw data. New data, DML or DDL, raw data, SIM. Okay, reference data, DML, external stable, taxonomy list assessment layer, and lastly, master data, type of operational goal analytical, DML. So this is workload categories for ETL or CDC. Okay, so based on the data types, okay, the workloads, okay, the typical traits, okay, of ETL workloads and CDC as below lah. For the ETL, the traits is higher input output for longer bursts of time, high memory consumption, higher CPU utilization, large volume of data move across the network, large transaction cycle depending on the software and the programming model. Okay, for the CDC, the traits is higher input output for longer bursts of time. Okay, this is same with ETL. Okay, and then smaller volumes of data move across the network. Okay, so this one is different with ETL. ETL has large volume of data. Okay, larger file based operation, smaller transaction cycles, and more file management at the operating system level. Okay, before we move on to discussing how we think of the modern data warehouse design, okay, we need to understand how to measure, okay, the measurement, how to measure the workload. Okay, so this is a sort of guideline. Okay, in today's situation, okay, we focus on the database and the operation cycle time it takes to execute any unit of work and multiply that unit of work by resource cost from the infrastructure to arrive at the query cost per minute and throughput per minute. So that is a kind of measurement. Then from an LTP perspective, there are multiple types of measurement standard published by the Transaction Processing Council. Okay, the short for that is TPC. Okay, you can Google that. Okay, there is a standard measurement. Okay, published by this council. Okay, it's like standard measurement. Okay, you can also beside Google, you can also go to the website www.tpc.org. Okay, but here I listed the most known technique to measure workloads for data warehouse. So how we measure that is to calculate the sum of all parts. Okay, we sum all this. Okay, for the load process. Okay, we sum the start time, elapsed time, number of records affected, insert, update, delete, okay, build time, network throughput, disk throughput, CPU and memory utilization, and application server throughput. Okay, we sum all this, so we got the load process. Okay, for the query process, okay, what you need to measure is start time, elapsed time, number of table affected, input output cycles, input output weights, CPU weights, network throughput, disk throughput, memory utilization, number of records moved, application server throughput, and application server processing times. So all this. Okay, if we effectively measure and add all the different components, we will get a better picture that will help us to optimize the layers of architecture and better assist in the design of a new work architecture. So we need this all this measurement. There are several design limitations in the current data warehouse. Okay, so all these six are the current design limitation in the current data warehouse. Okay, first is sharding. Okay, because the RDBMS cannot shard data efficiently due to the ACID compliance rule. Okay, and then this architecture, this architecture for SAN, underperform, and due to the data architecture and data model issues, the data distribution is highly skewed, causing poor optimization to occur at the database layer. So that's the limitation. This architecture, data layout architecture. Okay, the data layout on the disk is a major performance inhibitor and contributes to higher workloads. Okay, the layout. Often there are large tables that are collocated in the same disk along with their index. Another issue is undersizing of disk or unit of storage, causing too many fragments on the same table and leading to excessive chaining. Okay, number 4 is underutilization of CPU. Right, in many systems, the CPU is always underutilized, and this needs to be corrected for efficient throughput and scalable thread management. So we need to utilize our CPU. Okay, and then the number 5 is underutilization of memory. Okay, just now is CPU and now is memory. Okay, a large amount of data integration often bypasses usage of memory and relies on this. Okay, this situation often use one or more smaller table and two or more large tables in a join. Efficient design on the query can result in the using the smaller tables in memory and larger tables can be processed in a combination of memory and disk. Okay, that is why it is important to design your workload lah. Okay, the memory. The last one is poor query design. Okay, a silent contributor to the workload situation is poorly designed query. So we need to design query more effectively. Okay, whether the queries are written by developers or generated based on the semantic layer integration in reporting tools. When a query complies and has a large number of joins, the workload typically increases across the system. Okay, one of the example is to generate star schema types of query on a third normal form. Okay, database model with some semantic layer in the database, including aggregate table and summary views. Okay, that's the current system design limitation. Okay, to overcome this, okay, we have the new workloads and big data, which will be discussed in the next slide. Alright, new workloads and big data. Okay, big data brings about a new definition to the world of workloads. Okay, apart from traditional challenges that exist in the world of data, the volume, velocity, variety, complexity, and ambiguous nature of big data, it creates a new class of challenge and issues. Okay, so big data also has an issues. Okay, the key set of challenge and issues that we need to understand regarding data in the big data world that include all this. Okay, first of all, data does not have a finite architecture and can have multiple formats. Data is self-contained and needs several external business rules to be created to interpret and process the data. Data has a minimal or zero concept of referential integrity. Data is not rational. Data needs more analytical processing. Data depends on metadata for creating context. Data has no specificity with volume or complexity. Data is semi-structured or unstructured. Data needs multiple cycles of processing. Data needs business rules for processing. Okay, and data needs more governance than data in the database. And lastly, data has no defined quality. Okay, all these challenges that we need to understand regarding data in the big data world. Okay, lastly, we're going to discuss about the big data workloads. Okay. Workload management in big data is completely different from the traditional data lah, of course, because it's involving in large data, different volume, variety, everything. Okay, the major areas where workload definition are important to understand for design and processing efficiency include this. Data is file based on acquisition and storage. Okay, this is the platform. What depends on the what kind of platform that you choose. Okay, whether you choose Hadoop, NoSQL, or any other technique. Okay, most of the data, big data is a file based. Okay, data is a file based. Okay, data processing will happen in 3 steps. First, discovery, second, analysis, and third is analytic. Okay, the discovery is in this step, the data is analyzed and categorized. Analysis, data is associated with master data and metadata, and lastly, analytics, data is converted to matrix and structured. Okay, there are 3 steps. Data processing. So for each of these 3 steps above, okay, discovery, analysis, analytics, it will bring a workload characteristic. For discovery, it will mandate interrogation of data by users. The data will need to be processed where it is and not moved across the network. So it's there. Okay, and the second one in analysis. Analysis will mandate passing of data with data visualization tools. Okay, this will require minimal transformation and movement of data across the network. Okay, there is a movement of data, but we make it minimal. And the last one is analytic. It require converting the data to a structured format and extracting for processing to the data warehouse or analytical engine. Right. So big data workloads are drastically different from the traditional workloads due to the fact that no database is involved in the processing of big data. Okay, this removes a large scalability constraint but adds more complexity to maintain file system driven consistency. Another key factor to remember is there is no transaction processing but rather data processing involved with processing big data. Big data workloads from an analytical perspective will be very similar to adding new data to the data warehouse. The key difference here is the tables that will be added are the narrow type, but the impact of the analytical model can be that of wide or narrow table that will become wide. So the workloads, the workload perspective is different. Okay, that's how different between big data workloads and traditional workload. Lastly, big data query workloads are more program execution of MapReduce code. Okay, this the Hadoop, okay, which is completely opposite of executing SQL and optimizing for SQL performance. Okay, so the major difference in big data workload management is the impact of tuning the data processing bottlenecks result in linear scalability and instant outcomes as opposed to the traditional data management. Okay, this is due to the file-based processing data. Okay, big data is a file-based. Okay, the self-contained nature of data and the maturity of the algorithm in the infrastructure itself. Okay, anyway, the technology choices is also important. So we're going to discuss more on the technology, okay, in the next chapter. So all this new technology applied to data warehouses in the next video. I think that's all for this workload management. Thank you for watching. See you in the next video.